#lab-grown human organs. Imagine waking up with a brand new heart that never belonged to anyone. No donor died, no waiting list existed, and yet it beats perfectly. Scientists say this future has already begun, but what happens next? Millions of people wait for life-saving organ transplants every year. Many never receive the call that could save their lives. But what if hospitals could simply grow replacement organs instead? That idea once sounded like impossible science fiction. Today, researchers are building living body parts inside specialized laboratories. The question is no longer if, but how far can this go? It all begins with something surprisingly small. Doctors collect a few ordinary cells from a patient's own body. Those tiny cells may hold the blueprint for an entire human organ. Scientists reprogram those cells into powerful stem cells. These remarkable cells can transform into almost any tissue imaginable. One incredible change opens the door to countless possibilities. Now comes the strangest machine in the story. A bioprinter stacks living cells like microscopic layers of ink. Could a printer really create something alive? Unlike ordinary printers, these machines never print plastic or metal. They carefully place living cells inside supportive biological gels. Each delicate layer slowly becomes something astonishing. Printing alone cannot create a working organ. The cells must organize, connect, and begin communicating naturally. That hidden transformation changes everything. The unfinished organ enters a warm chamber called a bioreactor. There, nutrients and oxygen imitate the conditions inside a human body. Suddenly, lifeless tissue starts behaving like living biology. Tiny blood vessels become the greatest challenge. Without them, even perfect organs quickly die from starvation. Can scientists solve nature's hardest engineering puzzle? Researchers discovered clever ways to grow microscopic blood vessel networks. Some even encourage cells to build those pathways themselves. Nature quietly becomes its own construction worker. Simple tissues arrived before complex organs. Scientists successfully created skin, cartilage, and miniature livers first. Each success made the impossible seem closer. Then came tiny beating hearts inside laboratory dishes. They contracted rhythmically without ever entering a human chest. Watching them raised an unsettling question. If a heart can beat outside a body, what defines life? The answer becomes more complicated with every scientific breakthrough. And the next discovery deepens that mystery. Miniature brains called organoids began forming organized neural activity. They're nowhere near conscious, yet they imitate real brain development. Some experts suddenly faced difficult ethical questions. Should every laboratory-grown organ receive the same moral consideration? Most scientists answer no, but debates continue growing louder. The science keeps moving faster than the rules. Meanwhile, patients desperately need solutions today. Thousands die every year waiting for compatible donor organs. Time remains humanity's greatest enemy. Lab-grown organs could eliminate dangerous transplant rejection. Because the cells come from the patient, the immune system recognizes them. That single advantage could change countless lives. Imagine never taking lifelong anti-rejection medication again. Imagine surgeries becoming safer with personalized replacement organs. The future suddenly feels much closer. Yet enormous obstacles still remain hidden behind exciting headlines. Growing a complete human kidney remains unbelievably difficult. Its intricate structure challenges even the world's smartest researchers. Livers present another incredible puzzle. They perform hundreds of chemical tasks every single day. Recreating that complexity tests modern science relentlessly. Scientists also face an uncomfortable economic reality. Creating one personalized organ currently costs enormous amounts of money. Who will afford these miracles first? Another question worries many people worldwide. Could wealthy patients gain access while others keep waiting? Medical breakthroughs often create unexpected social challenges. Then another possibility appears even stranger. Researchers hope to grow organs before patients actually need them. Preventive medicine could enter an entirely new era. Some laboratories are exploring organs enhanced beyond natural human limits. Better durability, longer lifespan, and stronger performance become tempting goals. Where should humanity draw the line? At that moment, medicine transforms into something much bigger. It stops asking how to save lives alone. Instead, it begins asking what humans should become. Every breakthrough creates fresh hope for waiting families. Every experiment also raises brand new ethical dilemmas. The balance grows more delicate each year. One day, donor waiting lists may disappear forever. Hospitals could manufacture replacement organs almost on demand. That future no longer feels impossible. The greatest twist is surprisingly simple. Scientists are not merely repairing the human body anymore. They're learning how to build it from the ground up. The next heart that saves someone's life may never have beaten before. The next kidney could begin inside a laboratory instead of a womb. And the future of medicine may already be growing quietly behind closed